Okay. Now the chapter for today. So we'll start a new chapter today. Hydrochloric and hydrogen chloride family study of compounds. So now we need to start a new chapter, and the name of the chapter is study of compound nitric acid. Study of compound nitric acid. So we know what is nitric acid. Nitric acid is HNO3, right? Nitric acid is HNO3. Now we need to study how nitric acid is prepared naturally as well as in the laboratory. Okay, so the first way, let's say, first subheading under nitric acid would be occurrence of nitric acid. Occurrence of nitric acid in atmosphere or free state. How and where does nitric acid, like where can you find nitric acid in the free state or in the atmosphere, right? So we know that our atmosphere is made up of nitrogen, right? Our atmosphere has nitrogen gas, it has oxygen gas, it has carbon dioxide gas, and it has lot of other gases mixed together, and all those gases mixed together form our atmosphere, right? So our air column that we breathe in has all these kind of gases. So for nitric acid, we need nitrogen, oxygen. We also have hydrogen gas floating around in the atmosphere, right? So we need all the three gases to form nitric acid, because nitric acid formula is HNO3. So what happens is during lightning means like energy discharge, like electric energy discharge. Lightning one, it's like a big energy discharge, right? That's like free energy that comes from two clouds colliding, right? So during lightning, nitrogen reacts with oxygen to form nitrogen oxide, right? 1 second. During lightning, nitrogen reacts with oxygen to form nitrogen oxide. So this is the first step that happens during lightning. Okay. During lightning means when some energy is supplied to this reaction. So why only during lightning? Because during lightning, there is some energy supplied. There is some energy supplied to the reaction, right? To the reaction. So when some energy is supplied to the reaction, this reaction will carry forward. This reaction will happen. So this is the first step in the formation of nitric acid, right? This is the first step in the formation of nitric acid. Then this nitrogen oxide further oxidizes to nitrogen dioxide. Okay. So this nitrogen oxide that formed as a result of the energy supplied during lightning reacts further with oxygen. Now we don't need lightning to form nitrogen dioxide. Then nitrogen dioxide later combines with water, atmospheric water vapor, to form nitric acid, and that comes down as rain. And this is the natural occurrence of HNO3. Okay. So first, natural occurrence of nitric acid is in the free state. It's in the atmosphere itself, right? So how is it formed? First, during lightning, so we call it acid rain, right? So acid rain, so acid rain, one of the acid that is present in acid rain is nitric acid, and it is directly formed in the atmosphere. So how is it formed? So when there is lightning, nitrogen and oxygen can combine together to form nitrogen oxide. So now that if that reaction happens, then nitrogen oxide can react with oxygen to form nitrogen dioxide, right? Nitrogen oxide reacts with oxygen to form nitrogen dioxide. Further, this nitrogen dioxide reacts with atmospheric water vapor or atmospheric water to form nitric acid. Okay, and this nitric acid comes down as rain. So this is the occurrence of nitric acid. Now, what happens is our plants that grow on soil, right? Our plants that grow on soil require nitrogen, right? Because nitrogen is one of the components that plants require in their lifetime for photosynthesis and to carry out operations in their like living body, right? Plants. So plants require nitrogen, but nitrogen in the earth is available only as gas in the atmosphere. So हाम्रोमा खाली nitrogen चाहिँ gaseous state मा मात्रै छ in the atmosphere. It's like plenty. Nitrogen is plenty. 70, around 70%, 68% is nitrogen only, right? So, but the problem is we don't want the nitrogen in the atmosphere because the nitrogen in the atmosphere is not useful to the plants because plants need nitrogen in the soil. So this process in which nitrogen is converted to a compound of nitrogen and then it goes directly into the soil is known as nitrogen fixation. Nitrogen fixation. I think biology ma padeko hola तिमीहरुले हो. यसलाई nitrogen fixation भन्छ. There are there are bacteria in the roots of plants that can do this thing, right? They can fixate atmospheric nitrogen to some compounds that is useful to the plants and thus bring it to the soil, right? So this process is known as nitrogen fixation, where you can fix the atmospheric nitrogen gas, convert it into some compounds that is useful to the plants and bring that compound to the soil so that the roots can absorb it, right? So this process is known as nitrogen fixation. This is one of the common process that happens in plants. Plants require nitrogen. They require nitrogen in form, like in any form. They require nitrogen in the form that they want, but you can supply it in like any combined state. This is one of the state where nitrogen can be supplied to the soil, and that process is known as nitrogen fixation. So this process is very important for plants as well. So it may be harmful to us. It may be harmful to us if the nitric acid formed is like very acidic. It can be harmful to some extent, right? It can cause damage to some properties and all those things, but it is very helpful to the plants. It goes directly into the soil and plants can directly fixate the nitrogen present in nitric acid so that they can use it for their metabolic purposes, right? So this process is known as nitrogen fixation. Nitrogen fixation is converting atmospheric nitrogen into some compounds that is useful for the plant in some form, right? So that is nitrogen fixation. Nitric acid is formed this way. Nitric acid is formed when lightning huँदाखेरि nitrogen reacts with oxygen to form nitrogen oxide. Then nitrogen oxide reacts further with oxygen to form nitrogen dioxide. Then nitrogen dioxide reacts with atmospheric water vapor or water to form nitric acid. Simple as that. Okay. So this is the first part of the chapter where we study the occurrence of nitric acid. Now, there is laboratory preparation of nitric acid, sorry. So, मैले अस्ति एउटा statement भनेको थिएँ. The statement read something like a low volatile acid can produce a high volatile acid. Low volatile acid can produce a high volatile acid. So now, in our case, the low volatile acid is sulfuric acid. Sulfuric acid is very less volatile, and high volatile acid is nitric acid. Sorry. So by using sulfuric acid, we can produce nitric acid. So that is the laboratory preparation. Laboratory preparation of HNO3. So in the laboratory preparation of HNO3, what we do is we react potassium nitrate, KNO3 plus H2SO4 to give K2SO4 plus HNO3 acid. So this is a low volatile acid. This is a high volatile acid. You made a statement. Low volatile acid can produce a high volatile acid from a reaction. So if a less volatile acid is made to react with something, there is a possibility that a high volatile acid is formed. It is always a possibility. Okay. So this is the thing that happens in this, what is the laboratory preparation of nitric acid, right? Laboratory preparation of nitric acid. So now I'll share you the screen where the diagram is there. So this is the laboratory preparation of nitric acid. So here, sulfuric acid is a non-volatile acid and produces volatile nitric acid on reacting with potassium nitrate or sodium nitrate. So this is very important statement. A less volatile or a non-volatile acid can form a higher volatile acid. So it can produce, sulfuric acid can produce a higher volatile acid like nitric acid on reacting with potassium nitrate or sodium nitrate. So these two reactions are ekdam important. So laboratory preparation ko lagi, you can write any of these two reactions. These two reactions are very, very important. So this is less than 200, more than 200 by K2SO4, K2SO4 plus HNO3 huncha, Na2SO4 plus HNO3 huncha. So the reaction went something like this. So this is above 200 degrees Celsius, and there is another reaction like NaNO3 plus H2SO4, similar kind of reaction, but this is less than 200 degrees Celsius. You get NaHSO4 plus HNO3. Very simple, right? So if I bring the temperature down to less than 200 degrees Celsius, we get an acid salt. This is an acid salt. So your statement I had emphasized a lot when I taught you like previous HCl. I had emphasized the statement a lot. Yeah, when the same thing, if the temperature is greater than 200, we don't get an acid salt, we get a normal salt, right? And this one is preferred over this one. The less than 200 degrees Celsius wala is preferred because we still get nitric acid as the product. This one is preferred. This one is the preferred reaction over the previous one. This one is the preferred reaction over this one. This is not preferred because all the apparatus that is used in the laboratory preparation of nitric acid is made from glass, right? So sabai kura glass le banako huncha. The round bottom flask, connecting flask, sabai glass le banako huncha. Everything is made of glass. And at higher temperatures, there is a possibility that the glass may break. So to prevent that possibility, like to not make that possibility not happen, so we use this reaction. This reaction is more viable. This reaction is more frequently used, where the temperature is less than 200 degrees Celsius, and the product form is an acid salt. Okay, so product formed is an acid salt, and the temperature is less than 200 degrees Celsius. We get nitric acid, and this one is preferred because every component of the apparatus is made up of glass, and there is a very high tendency that glass may break at very high temperatures. Okay, so you need to keep that in mind. Any doubt? Your part, someone? Get out, someone. You can type it, or you can unmute yourself and ask me. Okay, so if you don't have any doubts, I'll continue. So there are physical properties of nitric acid that you can find in the book. It'll not be asked anywhere, but still, if you want to know about it, it is there in the book. So it is a colorless liquid. So nitric acid is a colorless liquid. It just looks like water. But the ones that you can buy are called commercial nitric acids. Okay, these things that you can buy are known as commercial nitric acid. These are yellow in color. These are a little bit yellow in color because of the concentration. So pure nitric acid, which is like around 98% or 97% acid, is colorless. Okay, they don't have any color. But the commercially available nitric acids, the acids that are sold and we can buy those acids, are like around 65-66% acid. Those are yellow in color, right? nitric acid fumes. Nitric acid is a volatile acid, so which means nitric acid will form fumes when exposed to atmosphere. So the fumes have a suffocating odor, like they smell, they have a suffocating odor. They feel like, it feels like you're getting suffocated if you smell nitric acid, right? So nitric acid has a suffocating odor, smell. um it is, and you know that nitric acid is, uh like I told you just before, like nitric acid fumes in air, fumes in moist air. So if you don't close the lid of nitric acid beaker, nitric acid that you collected will eventually go off. It'll be completely lost in the atmosphere, right? It'll be completely lost in the atmosphere. So nitric acid, let's say you have to cover it properly. The lid should be properly covered and kept in appropriate temperature. Nitric acid is extremely acidic. It is a very strong acid, so it'll have a very sour taste. Acids, they smell very sour, they taste very sour. If they are very strong acid, they smell even sour. So nitric acid will have a strong sour taste, acidic taste, right? And one more thing you need to know, nitric acid is very much soluble in water. So whenever you collect nitric acid, you don't collect it over water, because like water and nitric acid will combine together in all proportions. Like you can combine nitric acid and water in all proportion. You get concentrated nitric acid, you get dilute nitric acid. So if you don't like mix it with water, you get the highest concentration of nitric acid. That'll be around 97-98% nitric acid. Or you can add water to reduce its concentration. You can bring it down to commercially available nitric acid, that is around 65% nitric acid. So I'll tell you once again, it is a colorless gas in the purest state. Like it is like when it is 98% pure, 97% pure, it is colorless. Commercially available nitric acids are a little bit yellow in color. Then we have odor. It has a suffocating odor. It's the fumes of nitric acid have a suffocating smell. Taste, these are acidic tasting or sour tasting. Yeah. And they fume in moist air. They have the ability to fume and get like lost in air. So it is very important to close the lid of the beaker containing nitric acid. It is soluble in water in every proportion. So you can combine nitric acid in water in any proportion with water. It's very soluble in water, right? So your first semester we had done about acid, bases, and salts, right? So acid, base, and salt, there was distinction between how are acids identified and what are the different types of acids. So there was a term called basicity of acid, monobasic acid, dibasic acid, tribasic acid. So monobasic acid one was an acid that has only one free hydrogen. Dibasic acid one that has two free hydrogens. Tribasic acid that has three free hydrogen, right? So what nitric acid has only one hydrogen that is free. So nitric acid is a monobasic acid. Okay, it is a monobasic acid. So you will yaad karna generally. Nitric acid is a monobasic acid. Now let's go for some reactions. And as we'll do few reactions. I want you to complete that HCl part completely by today. I want the solution by tomorrow, like today evening, night. I want everyone to send me. So I want the solution of the entire HCl chapter, ICSE questions only, by today evening. Okay, so chemical properties. First thing that you need to know is nitric acid in the presence of heat will decompose into nitrogen dioxide plus what was it? Nitrogen dioxide plus water, I guess. Nitrogen dioxide plus water plus O2. Yeah, nitrogen dioxide plus water plus O2. So under heat, under the action of heat, nitric acid decomposes into nitrogen dioxide, water, and oxygen. So this is decomposition reaction. Decomposition decomposition reaction. Under heat, nitric acid decomposes into nitrogen dioxide, water, and oxygen. Number two, second reaction is neutralization reaction. Neutralization reaction. Neutralization reaction ma म एउटा acid र एउटा base react गर्छु. So this is my acid, this is my base. I get salt and water, NaNO3 plus water. So there are cases where I'll ask if anyone can answer this. If someone can answer, I'll ask you something. So I have nitric acid, but in place of the base, I write potassium oxide. But is this a base? What type of base is it called? What is this kind of thing called? If I say this is a base, but it is like it doesn't look like a base. Base भनेको त OH हुनुपर्छ, right? Hydroxide हुनुपर्छ. Hydroxide छैन यसमा, oxide मात्रै छ. So if I say this is a base, what is this kind of base called? What is this kind of substance called? First semester मा थियो, कसलाई थाहा छ यो?
Alkali.
No. Alkali भनेको त alkali metal ले बनाएको बेसलाई alkalis भन्छ. Alkali metal र alkaline earth metal ले बनाएको बेसलाई, जस्तै यो sodium hydroxide is an alkali. But I'm writing in place of alkali, I write a oxide, potassium oxide. So what is this kind of substance called? First semester में मैले emphasize पनि गरेको थिएँ. यसको नाम है, there is a name for this. No one knows this? Okay, amphoteric oxide ones. Amphoteric oxide. So amphoteric oxides are oxides that behave both as acid as well as basic oxides. So these oxides can behave as acidic oxides as well as basic oxides. So when you react, you get the same thing, KNO3 plus H2O. So this is the neutralization reaction where an acid reacts with the base. Acid reacts with the base. So this type of oxides that behave both as acid as well as base are known as amphoteric oxides. Okay, so maybe K2O, there is other example of amphoteric oxides like zinc oxides, but if you can write some oxides in place of bases, those are amphoteric oxides. Okay, amphoteric oxides are oxides that behave both as acids as well as bases. Then let's do carbonates and sulfates now. Carbonates and sulfates. So number 3 is it reacts with metal carbonates like sodium carbonate, Na2CO3 plus HNO3. Very simple. I have always told you, whenever there is carbonate, always carbon dioxide or water निस्किन्छ plus के हुन्छ त्यहाँदेखि NaNO3. So you get NaNO3 plus CO2 plus H2O. Or for example, you have another bicarbonate. कुन चाहिँ bicarbonate लिनु? So I'll take another bicarbonate. I'll take sodium bicarbonate. Sodium bicarbonate plus nitric acid gives you NaNO3 plus CO2 plus water. So this is a constant reaction, right? Here a salt one inside, carbon dioxide, water. So whenever it reacts with carbonates and bicarbonates of some metals, it will always give you carbon dioxide and water. That is very, very simple, very, very common reaction. Okay, then we have reaction with sulfates. Reaction with sulfites, I guess. Sulfites. Yeah. Metallic sulfites and bisulfites. So it reacts with metallic sulfites and bisulfites. So next topic is metallic sulfites and bisulfites. So metallic sulfites is K2SO3 or CuSO3. plus HNO3. Same thing, sulfides by the amro SO2 the water nishinja plus SO2 and water is the constant thing that comes out. You have any Cu NO3 2 plus SO2 plus water. Then we have bisulfides. So bisulfides ma amro calcium bisulfite CaHSO3 2 plus HNO3 gives you CaNO3 bracket 2 plus SO2 plus H2O. Always when something reacts with sulfides and bisulfides, you get sulfur dioxide and water. So sulfite भनेको चाहिँ SO3 हो, sulfate भनेको SO4 हो. So you should know the difference. Sulfite is SO3, sulfate is SO4. Okay, so the chemical properties are very simple. Nitric acid on heat, on reaction with heat, or on when subjected to heat, will decompose into nitrogen dioxide, water, and oxygen. Neutralization reaction, because it is an acid, it can react with alkalis or base to form salt and water. Very simple. It can react with metallic oxides as well, basic metallic oxides, or amphoteric oxides as well. So all the metallic oxides may not be amphoteric. There may be some metal oxides that are already basic. Okay, sabai metal oxide amphoteric huncha भन्ने छैन. Every metallic oxide need not be amphoteric. There may be metallic oxides that are actually basic. So nitric acid reacts with those kind of basic metallic oxides as well to form salt and water again. Then carbonates. Nitric acid reacts with metal carbonates to form carbon dioxide, water, and the salt. So this is the salt, carbon dioxide, and water. It reacts with metal bicarbonates to form the same salt, carbon dioxide, and water. Okay. Nitric acid reacts with sulfides and bisulfides of metal sulfides and metal bisulfides to form sulfur dioxide and water in all the cases. So I'll do till this point for today. Basic gardina, because I want you guys to complete the HCl wala homework. So if you have any doubts regarding this till now, just let me know. If you don't have any doubts, you can leave. We'll have our next class at 11.